UBindr allows you to publish data from your C# scripts to the Unity UI with minimal to no code changes. It supports two-way binding so that data changes made in the UI are passed back to the scripts and data changes made in scripts are passed forward to the UI. It serves a similar purpose as Angular, Knockout or React does in web applications. Basically, it makes building UIs easier and leaves the code cleaner. If you, for instance, have a settings component in your game that controls if sound is enabled or not, you can connect the values of that settings component to your settings UI without changing the settings script. UBindr makes it trivial to bind script values to text, drop-down, input field, and similar UI components. There is a text-based version of this tutorial and you will find the links in the description. Let's try it. I'm starting with a simple UI that I've designed and a settings script that matches the UI. I've also installed the UBindr asset in the project. The tutorial settings script contains a number of methods and properties that we'll bind to further on. But as you can see, there's no UI specific code in here. It's all POCO, plain old CLR object. First, I'll add the settings script to the canvas component. Next, I'll make it available to the bindings by adding a binding source. I'll set the source name to settings. That's how it will be referred to in the binding expressions. More on that later. I'm adding the binding source to the canvas because that makes things easier, but they could be separated if you preferred. Now I'll connect the music toggle to the music enabled field on the settings component. I'll add a UI binding to the music toggle. It will automatically determine that it's the isOn field that should be controlled by the binding. The UI binding knows about the different UI components in Unity. This means it can automatically determine if the binding should be a two-way binding or a one-way binding. Text labels support one-way binding and input fields support two-way bindings. It also knows what field to bind to. On a text component, it's the field named text. On a dropdown, it's the field named value. UBindr comes with a tool called Binding Helper. It gives you easy access to all binding sources that are available to the binding and an easy way to drill down into the fields, properties and methods of the source. A binding has both a source and a destination, and the destination is made available with the name dest. Typically, you'll copy data from the source to the destination, but there's nothing to stop you from doing it the other way around. Dest is just another source. The UI binding can automatically determine what the destination field is, but it can't automatically determine what source field to use. For our demo, let's connect it to the settings.music enabled field. That's it. The settings toggle is now two-way bound to the backing field music enabled. Two-way means that changes made on the C# side will show up in the UI and changes made on the UI side will show up in the code. We can demonstrate that by selecting the settings component when toggling the toggle in the UI. The component is updated accordingly. Let's hook up a binding for the sound effects toggle as well. Checking that our binding works correctly by accessing the settings component in the inspector quickly becomes boring, so we'll instead use a text component called status text. The UI component will assume that if you bind to a text component, you'll want to use the initial value of the text component as the source expression. You can override this behavior if you wish, but it's handy to be able to see the expression that it will bind to in the UI as you're designing it. I've pre-populated the text field with an appropriate text string. As you may notice, UBindr handles strings in a format similar to C# string interpolation. In fact, it's a subset of C# string interpolations. You can read more about string interpolations online, but it's very powerful and allows you to easily generate complex strings. Running the UI demonstrates that the binding correctly connects from the tutorial settings component to the text field. Next, let's connect these sliders. First, this music volume slider, and we'll connect that to the field called music volume. You'll notice that the range is limited from 0 to 100, and that will limit the values of the min value and the max value of the actual slider as it's been bound. So let's add a UI binding. And let's connect it to the settings, music volume. And as I click on the source button, it copies the value that I've selected here, settings.musicvolume, into the source field, like this. Now if I run the game, you will notice how they're connected. This one isn't done yet. So the binding is working for the music volume. Same thing again, add a binding, a UI binding, and connect it to the sound effects volume, copy to source, run the application, and now they're both bound. One more thing we would want to do, perhaps, is to limit the ability to edit the slider when the music is disabled. And we do this using a different kind of binding that's called a UI Interactable Binding. So if we add that to the slider, it automatically knows that it should update the destination interactable field. And we will bind that to music enabled. So only when music enabled will we be able to edit the music volume slider. It's enabled, we disable the music, and the slider becomes disabled as well. Do the same thing to the sound effects slider. So a UI interactable binding. We bind it to sound effects enabled, copy it to source, and we run it. It becomes disabled when we disable the sound effects. Next, we'll connect the settings message input field to the message field in the settings script. When we run it, you'll notice how it's been updated. And when we change it, we can see that the binding is two-way as well. Next, we will bind this drop-down to the difficulty field using the difficulties as our options. So the first thing we do is add a UI binding, and we bind it to the difficulty. The difficulty will control the value field, as you can see here, of the drop-down. So this is the value field. And to bind the options, we can enter a different expression in the options expression. This is only available when you're editing a UI binding for an options UI component. And we want to bind that to difficulties. Now there's no button to copy this expression to the options expression, but as soon as you click on it, it becomes available in your copy buffer, so you just need to paste it. Now if we run it, you can see how the value is correctly bound to the difficulty, and the list of difficulties is also properly connected. Lastly, we will bind the SoundFest button to the SoundFest method that's available on the settings, tutorial settings. Now there are ways of doing this using regular Unity UI, but we will use something called a method binding instead. And the reason to do that is it supplies us with a nice drill down method. And now it should properly execute the method when we press the button. Again, we can limit the interactability of the button by adding a UI interactable binding, and we can make it so that you cannot press the button unless the music enabled is set to true. But perhaps we also want to make sure that the sound effects enabled is true as well. So if either of those are disabled, the SoundFest button is disabled also. Next, we're going to look at how to create lists of your objects in UBindr. And for this example, we're going to work with a high score list script instead of the tutorial setting script. It contains a list of players, and each player has a name and a score. The first thing we'll do is add the high score list to the canvas, and then we'll add a binding source to enable us to bind to it. I'll call the source name high score. And in this list, the inner list, I will add a repeat binding component. And the repeat binding is the type of binding that UBindr provides to support lists. And it has a source expression, and it expects you to provide a list of some kind. If you provide something that isn't a list, you will get a warning. So if I add the selected player property, it says that it returns something that isn't a list. Expect source to implement IEnumerable. If we pick the players list instead, we get the message that no prefab is provided. And how this component works is that it iterates through the list of players, and for each player it finds, it will instantiate one copy of the prefab you provide. In this case, I've pre-generated a prefab called player prefab, and I will add that to the list as well. Anything placed in the list as the game starts will be deleted. It will only use the prefab provided in the item prefab property. Anything else will be deleted, but we can add it so that we get a good sense of what the UI will look like. The repeat binding provides a field called row source name. This is the name that each row will have access to in its list of sources. That represents the row items from the, in this case, the players list. So if you can see here, I have a field called row with the properties name and score. And if I select the text field here, row name, this is bound to the row name, which is this field. If I hit play, I get a list of players. The players are sorted in the same order that they exist in the list in the high score list. And if we want to change the sort order, there is a property called order by. So if we enter row.score, it will be sorted by the score. The high score comes first, and they keep falling, and it's because it's set to sort descendingly. If we set it to sort ascendingly, it will sort the other order. And if we sort them by negative score and descending, well, that's just crazy. But anyway, the reason that we can click to select the different rows is that we have a binding on a panel, a blue transparent panel, that states that if the high score.selected player equals the current row that this panel finds itself on, then the panel should be visible. Otherwise, it should not be visible. So that's a simple way for us to update the GUI to show which row has been selected. There's also an event trigger on the row itself that will detect any clicks and run the method selectMe on the current row as the rows are clicked. And that works by us having an event trigger placed on the row with a pointer click event type. So we can add any event type from this list and then add a method binding. And the method binding will find this list and inject itself, making sure that row selectMe is executed whenever any item in this list is clicked. We also have a button to delete the row, and that will call the row.deleteMe. We have a minus button and a plus button. The minus button will call the method change score with the property -1, and the plus button will call the change score method with the value of +1. And if we run the game, we will find that indeed increasing the value, and as the scores change, the sort order will also change, and that's taken care of by the sorting mechanism. The delete also works. Now let's bind this input field to the name property of the selected player. So a UI binding, and let's set it to selected player.name. This time copy destination to source expression doesn't work because the text field doesn't contain a proper source expression. So we'll disable copy destination to source expression and manually use this source expression. If we run it, we're able to edit the name value of the selected player. Now we may want to avoid the user being able to edit this field if there is no selected player. So let's add a UI Interactable Binding, and let's hook it to the high score selected player. And in this case, we're gonna do high score players contains if the list of players contains the selected player, we will allow editing the name, otherwise it will be disabled. If I hit delete, you can see how this becomes disabled. The reason that we check that the high score players list contains the selected player is that the delete button doesn't actually set the current player, the selected player, to null. So the high score list .singleton.selected player will be set even though we delete the player from the list. So this prevents a situation where we would still be able to edit a deleted player. The add button can be connected to a method binding, where the higher score has an add player method, which adds a random player. As you see, the list becomes very large after a while, and we can prevent that by editing the repeat binding and limiting how many players are allowed to exist in the list. And it will apply the sort order on which ones it renders. 12 is obviously not the correct number. Let's make it 9. And if I delete items, new ones will appear from the bottom. And that's it for this tutorial of UBindr. We suggest that you also look at the all-in-one scene that's included in the UBindr asset package. It contains demos on how to control the graphical layout of items using UBindr, such as these sliders or this health bar. They're both implemented without any code changes. It also demonstrates how UBindr can be used to control positioning of items in lists, which would facilitate this type of sliding motion as things are added or deleted.